Our Indian civilization is one of the ancient civilizations ever recorded in history. I was surprised to know certain things which are such a country with a marvelous agricultural background was inflicted with. After independence till 1960, India was expecting wheat and rice from Pandit Jawaharlal Nehru, the first Prime Minister of India, made a statement that everything can wait but not. If situation of India continues in this way, soon the people would die out. Then the question is how situation changed. There comes a person from our South India Hi friends, hope you're all doing well. Our Indian civilization is known for its glory and is one of the ancient civilization ever recorded in history. We had our own culture, literature, education, engineering, architecture and agriculture. I was curious to know the quality of agriculture that we had in ancient times that made me to refer some ancient literature and text. I was surprised to know certain things which I will put forth in 4 major points. First is, we were self-reliant with agriculture. We were able to have the maximum outcome from the agriculture. We were self-reliant, we were able to store and we were able to give it to others. Second, we gave priority to agriculture. We never treated agriculture as secondary. Third is, our agriculture was an eco-friendly approach encompassing a concept called as Vasudhaiva Kutumbakam, web of life, taking everyone into consideration, their safety, their welfare. And fourth is, we had a clear vision with respect to the objective and practices in agriculture. Such a glorious agricultural history that India had. Friends, unfortunately, such a country with a marvelous agricultural background was inflicted with Bengal famine. And the situation took years to get back to normalcy. After independence till 1960, India was expecting wheat and rice from United States of America. Concept we normally call it as a ship-to-mouth experience. Pandit Jawaharlal Nehru, the first Prime Minister of India, made a statement that everything can wait but not agriculture. A famous person quoted that if situation of India continues in this way, soon the people would die out of famine and poverty. Friends, this was the situation of India around independence and 1 or 2 decades after post-independence. Then, the question is how situation changed. There comes a person from our South India called Prof. Swaminathan, whom we call it as father of Green Revolution. So he revolutionized some agricultural practices which we call it as a Green Revolution. So this discussion is going to talk about a brief introduction about Professor Swaminathan, what is called as Green Revolution, what are the practices or changes that he made in Green Revolution? Is Green Revolution really that effective? Is there any further modulations required in Green Revolution to make Green Revolution into Evergreen Revolution? So these are the various questions that comes in our mind. And friends, this video is going to give answers for all these questions. So please stay with us till the end to get the answers and enjoy the discussion. So let's have the basic details of Professor Swaminathan. So he was born on 7th August 1925 from a town called as Kumbakonam in Tamil Nadu. So he was second son of Dr. M.K. Sambasivan, who was a physician that time, a medical practitioner, and Srimati Parvati Tangammal Sambasivan. So initially being born to a father who is a medical practitioner, so he was initially oriented towards his medical education, for which he did his BSc Zoology in Maharaja's College, Thiruvananthapuram. But right from the initial days, due to Bengal famine and the introductory part that we had seen, he was much more oriented towards the agricultural sciences. So he joined BSc Agricultural Sciences Coimbatore Agricultural University. Then further Master of Science, Agricultural Sciences from a premier most institute, Indian Agriculture Research Institute, New Delhi. We'll be seeing in a couple of minutes that he became the director of that institute later. And further he did some research in Agriculture University in Netherlands, and he obtained his PhD from Cambridge University, UK. Then he did his postdoctoral research from Wisconsin University, United States of America. Friends, these are all a brief biodata regarding Professor MS. So let's quickly get into his research part. What did he contribute to the agricultural sciences? First, during his tenure of postdoctoral research in Wisconsin University, he made a hybrid potato, transferred a gene that confer resistant to abiotic and biotic stress. So here it is going to be an abiotic stress. Abiotic stress is nothing but a frost. So potato was not that much withstand the frost. So he made a frost resistant potato, which is called as Alaska frostless. Okay, so this was his initial outcome work done from Wisconsin University, United States of America during his postdoctoral research. Following this, he was given a job, a post in Wisconsin University, but he refused to accept that, and he came back to India mainly with the view of serving Indians. As I said, that Indians was severely afflicted with famine and underproduction of grains that time, right? So once he came back to India, after some time, he was a part of Indica Japonica rice hybridization program, so which was done in Central Rice Research Institute. We normally call it as CRRI Cuttack. Okay, so what did he do here? He made rice cultivars or strain response to fertilizer. The point here is, when you add fertilizer, the yield or production of rice was significantly increased. So this was the main contribution here. So fertilizer responsive varieties of rice. So this rice varieties produced through this method were ADT 27 Razi. Okay, and he considered this as a foresight for green revolution that is about to happen in coming years, right? So this was his initial research participation through Indica Japonica rice hybridization program at CRRI Cuttack, right? From CRRI, he went back to IARI. In IARI, his research was mainly focused on basic sciences. I can say research can be either a conceptual research or an applied research. So he was the research done at IARI was mainly a conceptual research in knowing things rather than applied research, right? Now you could see, I could list some of his work that has been carried out by him in IARI New Delhi. There is structure of chromatid elucidation, mitosis in yeast, then mechanism of ionizing radiation, chemical mutagenesis, polyploid wheats, gamma garden establishment, Drosophila genetics. So human cytogenetics. These are some of the works that has been done by Professor MS during his tenure as a scientist in IARI. Okay. Now the situation here is, India was a begging bowl. Very pathetic situation. India was a begging bowl. So his ideas made him to shift from his basic research, that is the conceptual research, to an applied one. So what things were running in his mind was how his research experience would provide a solution for the present situation, right? So there comes the famous Bengal famine, which we had 1942 to 1945. As I said previously, our Pandit Nehru said everything else can wait, but not agriculture. So these were the intuitions, these were the inspirations that made Professor MS to get into this green revolution. Friends, look here, 10 million tons of PL80 wheat were imported from US in 1966. In a country which was originally self-reliant in terms of agricultural outputs. And as I said, there is a ship-to-mouth existence. Annie and Paul Ehrlich's statements in their book Population Bomb stated that if no nuclear attack would happen to India, they would die out of famine. Okay, food scarcity. You could see the graph here. This is a wheat production in million ton. In 1947, you could see 6 million tons. And in 1962, there is a just 10 million ton, you see a 4 million ton increase. Okay, we had a great scientist called as Malthus, whose observation was, we have two things. One is the rate of increase of population, other one is rate of increase of resources. Rate of increase of population is comparatively more than the rate of increase of resources. So thereby we see a increase in competition. I hope you can understand this concept. As the population increase, though there is an increase, but this is not on par with the rate of increase of population. So this was the situation that made India a begging bowl. So this was situation. So this actually motivated, inspired Professor MS, he made a begging bowl to a bread basket through Green Revolution. So what did he do? First thing is, I said during his initial research in CRRI, he made some rice strains that were responsive to fertilizer. The moment we add chemical fertilizer, the production will naturally increase. So the same thing he made in wheat here. Okay, so fertilizer responsiveness, one thing, and second thing is, this is one important interesting concept, reduction in height of plants without reducing the length of grain bearing the panicle. We call this as a semi-dwarf variety. See, some wheat are tall, some wheat are dwarf. The problem with tallness is, you could see here, this is a tall variety, this is a dwarf, this is a semi-dwarf variety. The problem in tallness is, since there is a weighted panicle is nothing but a group of grains, wheat grains present, we generally call it as in technical term panicle. What happens due to weight, the entire plant, breaks down, and we call this process as lodging. Now you could see here, either due to weight or if there's going to be a high velocity wind, the entire, the wheat lodges. So thereby there was a significant reduction in yield. So whatever the farmer makes is completely will come down due to this lodging process, right? So thereby he made a semi-dwarf variety. That is, the plant will not be too tall so that lodging happens, or plant will not be too dwarf, right? He made a semi-dwarf variety, and friends, these two are the main thing that revolutionized the agricultural output, okay, which we can say it as the pillars of Green Revolution. Though we are discussing this in 5-10 minutes, but the exact time that he took to do these things was many years, okay, the intensive labor and hard work that people have invested. Now, how did he do semi-dwarf variety? Now, I hope you understand the concept behind using semi-dwarf variety to prevent lodging. Okay. Now, initially he tried some interspecific hybridization by crossing the wheat plant with other species, some chemical mutagenesis, induced radiations, and plant growth regulators. So these were the initial things that he tried, but the results were not that impressive. So he went for dwarfing genes, that is Norin-10 gene from Norin-10 wheat Japan. He got that gene and called it as gene cloning. So he introduced this gene to the Indian variety. So obviously the Indian varieties were semi-dwarf, and SD1 gene from Diju Wu gen from China in case of rice, right? And for this process, he got introduced to a great scientist, food scientist called Professor Norman E. Borlaug, the then director of CIMMYT Mexico, right? He was also happens to be a Nobel laureate, and this made a friendship between Professor MS and Professor Borlaug, right? And their friendship continued forever. Now, you could see here, after these two changes, that is increasing the fertilizer responsiveness of the plant and then making semi-dwarf varieties, you could see in 1947 it was 6, 1962 it was 10, and in 1964 to 68 you could see it was 70. 6 to 4, 10 to 70. This is the highlight of Green Revolution, and India had celebrated Green Revolution. You could see the then Prime Minister, Madam Indira Gandhi, she released a stamp indicating the wheat revolution. But friends, what is the actual, though in one view the Green Revolution revolutionized the agricultural practices, the India became self-reliant, but Professor MS was not happy. Let's see the reason. See, we were using the excessive use of chemical fertilizers and pesticides. So obviously we people consume that and we end up with many diseases including cancer. So this is one point I hope you all realize. Second thing is monocropping. So we use only a particular crop that will give a high yield. So other crops naturally get eliminated, become extinct. So monocropping. So even monocropping, the ecosystem, the environmental aspects will also get disturbed. Okay, so that is a separate discussion. And excessive irrigation, underground water level will come down. And finally, to summarize, there is no proper attention to ecological foundation. We are not at all bothered about the ecosystem or the other plants or animals. What we are bothered about only the productivity. We need, we have to use the fertilizer, get the product, eat it, and this green revolution did not provide much of botheration to the surrounding ecosystem. So that's the reason no attention to ecological foundation, right? Now, there was a statement by Evo Wilson. The problem before us is we need to. It's a very embarrassing situation. You could see this. How to feed billions of new mouth. You have to feed for several decades and save the rest at the same time. See, we have to use green revolution to feed people, new people, right? Existing people. At the same time, on the other hand, the green revolution has got an impact, and we should also save the other people. So I said there is a benefit here, and you can also see the risk. So it has to be equally balanced, right? What next then? We should have whatever problem the green revolution has should be addressed. See, there is no point in leaving out the green revolution. We know of the situation in India before the green revolution. So the green revolution is the one thing that is required. Okay, but it has to be fine-tuned. So when such fine-tuning is done, then the green revolution will be an evergreen revolution. It won't be a green revolution, but it will be an evergreen revolution. So what has to be addressed? So agriculture has to go with ecosystem so that you get an eco-agricultural approach, right? The environmental aspect should be associated, should be attached with the agricultural practices. The original green revolution insisted only on agricultural practices. That's the reason why MS wanted to have an evergreen revolution. So it has to go with the ecosystem, right? So what did he do? He established the MS Swaminathan Research Foundation, MSSRF, I hope in the year 1988, if I'm not wrong. So this research foundation not only focuses on agriculture, it also focuses on research, it also focuses on the surrounding, we can say sustainable agriculture, considering all the aspects of ecosystem. You can go to their website and see, okay, what they do, fisheries, they do some, some aspects about soil, right? So this is reason behind Professor MS to establishing this center, and he insisted scientific approaches, okay, making some hybrid variety, always ensuring that it is going to be safer to the people. He was very particular with that through genetic engineering, and he always insisted that the science and scientist perspective is not just to get the publication or patent, which is one of the credits that science or scientists can have. It should be always oriented towards the benefit of people. This notion he insisted very much. The entire science has to, especially here with respect to agriculture, should look what people need in getting an evergreen revolution. Okay, people should not be just self-sustained with getting a publication and a patent. So this is one thing. And he also insisted one thing called as participatory breeding. What is participatory breeding? A farmer should be given choice with the different varieties of plants. As we have said, the green revolution insisted on monocropping, the crop that gives maximum yield. Okay, that is going to eliminate all the other crops. To address that issue, he brought here a concept called as participatory breeding. Here the farmer will be educated, he will be given a lot of options. So this is mainly to bring even all the other yields that is suitable for that particular environment. And anticipatory research. In this respect, MS Swaminathan Research Foundation, they made a salinity resistance rice by transferring a saline resistance gene from a mangrove plant Avicennia. So they all predicted that due to this global warming and melting of glaciers, there is going to be a level of increase in the sea water level, thereby the groundwater will naturally become saline. So we should have some plants that is capable of growing even in saline condition. So that's the reason they brought salinity resistant rice, right? Things are all still in research. I'm not sure whether these plants are brought into fields. I'm not sure. If anyone knows can comment here. These are all the anticipatory research. He believed that green revolution, which is actually a green revolution, will become an evergreen revolution. Right? So this was the sole dream. Okay, the purpose of green revolution is to serve mankind to its fullest. Shouldn't be a greed revolution. should be just a breathing space, not a permanent thing, okay, where farmers can invest, right? So friends, I believe I have summarized important aspects of Professor MS contribution in Green Revolution. It has a lot of scientific things, so I have made as simple as possible in bringing these details to a common man. One important thing is, we had a glorious past, we had a bad phase around independence, and this Green Revolution took us to a comfortable position in terms of agriculture. But this green revolution should be fine-tuned due to various reasons to an evergreen revolution. So this is the concept. So we are very much indebted to Professor MS for his initiation towards green revolution and for his aspiration towards evergreen revolution, without which we people would not be comfortable with agricultural aspects till today. We lost him almost a month before, so I thought of making a video on his contribution. So hope you would have enjoyed this, and if you have any suggestions or comments, so please do express to us. A lot of things are available regarding MS contribution, his life and everything. So this I have taken from his website. I had some information, I have made that, compiled that into a discussion here. So if there could be any changes here and there, so please do let us know. Okay. And friends, here there are all some important positions that he held. You could see here. So he was the director of IARI, I initially said. So he did his MSc there, and finally he became the director. And in between he had some basic research also done there, and he was DG ICAR. ICAR is, this is Indian Agriculture Research Institute, IARI, and this is Indian Council of Agriculture Research, for which he was Director General. Actually his daughter, Professor Swaminathan, was head of ICMR, especially during the COVID time, around COVID time, not sure. Then he finally became Secretary to Government of India, Department of Agricultural Research and Education. Then Principal Secretary to Ministry of Agriculture, Acting Deputy Chairman and Member of Planning Commission, and Director General IARI Philippines. He was also a Member of Parliament in Rajya Sabha for 5 years. He also received prestigious awards and honors. Friends, thanks for watching this video. So please do comment. We'll meet in another video with an interesting information. Thank you.